Okay, diagram 1.1 show a spoon appear bent in water due to a light phenomenon. Alright, so tick for the correct answer in the box provided. What is the light phenomenon? So this is very simple. This is obviously refraction of light. Okay, refraction of light. So make sure you read the question. The question asks you to tick. So make sure that you tick lah. You don't do any other thing. Okay, like if you tick outside, is considered as wrong. Okay, because the question asks you to tick in the box. So if you tick outside the box or you cross inside the box, okay, any other sign it will be considered as wrong. And of course, don't tick 2 lah. Okay, if you tick 2, then the wrong one will cancel off the right one. Okay. So make sure that if you change your answer, make sure that you erase the wrong answer clean lah, okay? Erase it clean, okay? Don't leave any sign. If a little bit, okay, still okay lah, okay? But make sure that the one that you mark correct and the one that you mark that the one you want to erase off is obviously different lah, okay? Clear different. Alright, so next. Okay, next. State a physical quantity that changes when light propagates from water to air. Okay, so what is the physical quantity that changes when light propagates from water to air? So it is the speed of light. Okay, speed of light change when propagate between medium of different optical density. So when go from low optical density to high optical density, then the speed will decrease. And when go from high optical density to low optical density, then the speed will increase. Alright. So next. Complete the ray diagram to show the refraction of light that occur on the spoon in diagram 1.2. Okay, so here we need to draw a ray diagram. Okay, so the ray diagram that we can draw here, you see this is the object. Okay, this is the object. So the light come from the object and go out from the water. And since they already draw for you the direction of the light outside of the water, inside the air, then that means the light go from the object to this point. Okay? Make sure that you got draw the arrow to show the direction of the light. Okay? This is very important. Arrow to show direction of light. Usually in ray diagram, what mistake that a lot of students make is that they forgot to draw the arrow to show direction. Okay? Next is you need to draw the line that show where do the image appears to be. Because the light go from water to air, the speed of light will increase, so the light will refract away from normal. Okay, it will bend away from normal, refract away from normal, go into the eye like this. So from the point of view of the eye, it will look like, okay, from the point of view of the eye, it look like the light come from here. Okay, it looks like the light come from here. Okay, looks like the light come from here. So the line to show the direction of the light, apparently the light come from here, you must draw using dotted line. Okay, using dotted line. So this question have 2 marks. So 1 mark is for the line, for the actual light together with the arrow, and then another mark for the dotted line that show the path or the direction of the image. Okay, again, So the actual light comes from the object and reflect away from normal into the eye. So from the point of view of the eye, it will look like the light come from this direction. Okay, it looks like the light come from this direction. So if the light looks like come from here, so you will see the image here lah. Okay, see the image here. But actually, any light here or not? Actually, there is no light. Okay, there are no light over here. It just looks like the light come from here. Okay, all right. So next. Okay, if you have any question, you can just ask. Okay, on this cathode, there is a light sensitive metal on this cathode. So that means when the light shine on the cathode will have photoelectric effect. Okay, the cathode will have photoelectric effect. That means the electron can escape from the surface of the cathode. And because the cathode is connected to negative, right? So it will repel the electron towards the anode, which is positive. So that means when there's light shine on the photocell, you will have photoelectric effect and the circuit will be complete. Okay, the circuit will be complete. That means the electron can flow. So if the electron can flow, that means you have current. Okay, you will have electric current. So it says that when the car block the light, the door will open. That means when got light shine on photocell, the door close. When no light, then the door will open. Okay? Alright. So the photoelectric effect occur at cathode when the light radiation is directed to it. What is photoelectric effect? Okay, photoelectric effect. Okay, so this is the emission of electron from metal when the metal surface is illuminated by light at certain frequency. Okay, so what are the important keywords here? Emission of electron from metal when metal surface illuminated by light at certain frequency. So this is emission of electron from metal, okay, from metal when metal surface illuminated by light at certain frequency. So these are words that are very important, okay, very important, especially this at certain frequency. Why only at certain frequency? Okay, why illuminated by light at certain frequency? Because the photoelectric effect only occur when the frequency of the light is greater than or equal to the threshold frequency of the metal. Okay, so if that means if the frequency is lower than the threshold frequency, then there will be no photoelectric effect. Okay. Alright. For this word illuminated, if you cannot remember the word illuminated, you can also replace with like shine by light. Okay, or when light fall on the metal surface. Okay, it is not necessary to use the word illuminated as long as you have you write a word or a sentence that can give the meaning where light fall on the metal surface. Okay, then is already enough. So not necessary to use the word illuminated. Alright? Okay. Next. The threshold frequency for the cathode metal is 5.16 times 10 power by 14 Hz. The light radiation directed to the cathode has a wavelength of 560 nanometer. Calculate the maximum kinetic energy of the photoelectron emitted from the metal surface of the cathode. Okay, so this is, we answer this with the equation of Einstein's photoelectric theory. Okay, so Einstein's photoelectric theory, the equation is for us to calculate the maximum kinetic energy. So basically it's like this. The maximum kinetic energy of the photoelectron will be equal to the total light. Oh, sorry, not the total energy from the photon. Okay, energy from the photon. Okay, that is absorbed by the electron minus the work function. Okay, minus the work function. Basically, this means that the photon have energy that is greater than the work function. Work function, okay, this one, the work function is this is the work function. Work function is the minimum energy needed for the electron to escape the metal surface. Okay, work function is minimum energy that is needed for electron to escape. Okay, this E, this is the energy of photon. Okay, so that means when we have one photon meet with the electron will absorb the energy from that photon. So if the photon have more energy than the work function of the metal, okay, have more energy than the work function of the metal, then the extra energy will be converted into the kinetic energy of the electron. Okay? Alright, so maximum kinetic energy equals to, okay, so this is the, we want to calculate the energy of the photon. So the energy of the photon is equal to Planck constant times the frequency of the photon. But in this question, it doesn't give us the frequency, but it gives us the wavelength. So we can calculate the frequency from the wavelength and the speed of light. Okay, in order to calculate the work function is the minimum energy needed for the electron to escape. So we take the Planck constant times the threshold frequency. Okay, times the threshold frequency. Alright, so we get this one. We can convert into speed of light over the wavelength, because speed of light equal to the frequency of light times the wavelength. Okay, this comes from V equals to F lambda. Alright, so frequency equals to speed of light over the wavelength of the light. So now we substitute the value inside. Okay, Planck constant. Okay, you see in this question, it didn't write in this question. That means you have to check the second page of the question paper. Make sure you check the second page of the question paper for all the equation and the constant number. Okay, please don't just look at the question, oh, doesn't give the information and then cannot do. Okay, make sure you check the list of constant number and equation in front of the question paper. Okay. Alright, so this H is the Planck constant. Planck constant is 6.63 times 10 power by negative 34. Speed of light 3 times 10 power by 8 meter per second over the wavelength. So the wavelength is 560 nanometer minus the Planck constant 6.63 times 10 power by negative 34. Okay, times the times the threshold frequency 5.16 times 10 power by 14 hertz. Alright, so we will be able to get 1.31 times 10 power by negative 20 joule. Okay, so this is the maximum kinetic energy of the photoelectron. Okay. Okay, next, see here. If the frequency of the light radiation directed to the cathode is 5 times 10 power by 14 hertz, will the gate open? Okay, you see here. It says that the frequency of the light, is 5 times 10 power by 14 hertz. That means what? That means you see, this is the threshold frequency of the metal, 5.16 times 10 power by 14 hertz. So the threshold frequency is greater than the frequency of the light. So this means that the photon of the light do not have enough energy to cause photoelectric effect to occur. So if no photoelectric effect, that means no current. Okay, that means this one, no current. And the question says that if blocked, door will open. Okay, it says light transmitter and photocell. The gate will open if the light is directed to the photocell is blocked by a car. That means when no light, door will open, and when no light, that means no electric. Okay, no photoelectric effect, that means no current. No current, it will open. Okay, got current, it will close. So now that the frequency of the light is less than the threshold frequency, so this means that no current, so the door will open. So the question asks, will the gate open? Yes. Okay. Repeat D. Wait. D. Which part? Which part you don't understand about D? Oh, okay. Why this one minus? Alright. So you see, the concept of the photoelectric effect is that, okay, this is the electron. So when when got light shine on the electron, that means the photon of the light that carry energy meet with the electron, and the energy will be absorbed by the electron. So when the energy is enough, then the electron can escape the surface. Okay, electron can escape the surface. So basically is like this. We can write like this. So this is the energy of the photon equal to the work function. This W, work function, is the minimum energy needed for the electron to escape. So different type of metal, they have different work function. Okay, some metal have very high work function, some metal have very low work function. So that means some metal, the only need a little bit of energy, the electron can escape. Some metal need to absorb a lot of energy, then only the electron can escape. Okay, so if this photon have more energy than the work function of the metal, that means the photon have more than enough energy to make the electron release. So what will happen to the extra energy? The extra energy will also be absorbed by the electron. And what will happen to the extra energy? The extra energy will become the kinetic energy of the electron. Okay, kinetic energy of the photoelectron. So the total energy, so the energy in the photon equal to the work function of the electron. That means the minimum energy needed for the electron to escape plus the kinetic energy of the photoelectron. Okay, when the electron escape, we call it photoelectron. Photoelectron. Okay, so by rearranging this, if you want to calculate the maximum kinetic energy, then it will be the energy of the photon minus the work function. So that's how we get this. Okay, maximum kinetic energy equals to the energy of photon minus the work function. Okay, so this energy of photon, okay, we can calculate the energy of photon by using this equation. So energy of photon equals to the Planck constant times the frequency of the photon. Frequency of the photon is the frequency of the light of the photon. So for example, red light. Red light, we know that red light have lower frequency. Okay, red light has lower frequency, so that means the energy that is carried by the photon of red light will be lower. Okay, this is red light. For blue light have higher frequency. So blue light higher frequency, that means the photon of blue light will have more energy. Okay, so that means all the other electromagnetic wave is also the same. For example, radio wave carry the photon of radio wave carry the least amount of energy because the frequency of radio wave is very low. Microwave, higher frequency than radio wave, so the photon of microwave will have higher energy. Photon of infrared have higher energy than microwave. Photon of visible light have higher energy than infrared. And inside the visible light, we have red color light until blue, until purple color light, right? So red color light have lowest frequency. Blue color light have highest frequency inside the visible light. Okay, so red color light, the photon have less energy. Blue color light, the photon have higher energy. And higher frequency than visible light, we have ultraviolet ray. So the photon of ultraviolet ray have more energy than visible light. So of course X-ray, the photon have higher energy than ultraviolet, and gamma ray photon will have more energy than X-ray. Okay, like that. So this is how we get this one. Why this one E is changed into HF. This one work function. Okay, how to get this one? Because work function is the minimum energy that is needed for the electron to escape the surface. So that means the amount of energy can be calculated by taking the threshold frequency times the Planck constant, because the threshold frequency is the minimum frequency of light for photoelectric effect to happen. That means the minimum frequency of light for the electron to have enough energy to escape. Okay, so that means if the photon is have the frequency that is the same as the threshold frequency, then that means the photon only carry enough energy, just right, just enough for the electron to escape the surface, but don't have enough energy to give the electron kinetic energy. So that means the electron can escape the surface, but do not have kinetic energy to fly away. Okay, like that. So to calculate work function, we take the threshold frequency times the Planck constant. Okay, to calculate the minimum energy needed for photoelectric effect to happen for a certain metal. So different metal have different work function, and different metal will have their own threshold frequency. Okay. All right. So I hope that this can answer your question. Okay. I hope this answer your question. All right. Okay. Thank you for responding. Okay. So continue. Okay. So this one can understand why the gate can open. Okay, because the threshold, because the frequency of light is less than the threshold frequency, so that means no photoelectric effect. That means no current, and when no current, the door will open. Okay, like that. Okay, next, number 3. Diagram 3.1 show a circuit to investigate the conductivity of an electronic component X. Okay, so name the component X. So component X is obviously diode. Okay, yes, very good. Thank you very much. Okay, thank you for responding. Okay, it's a diode. Alright. Next, B. When the switch is on, the bulb does not light up. Why the bulb does not light up? Okay, you look at the circuit. So this side is positive, this side is negative. So that means the current need to flow this direction, but the diode is connected in reverse bias. Okay, so the current cannot pass through. So the reason is diode is reverse bias. Okay. Next, how the connection of the circuit in diagram 3.1 need to be modified so that the bulb can light up. Okay, what is it that we need to modify here? So the first one, the most obvious one is we can say that we reverse the connection of the diode. Okay, reverse connection of diode. So either this, or you also can say that you reverse the connection of the drive cell, also can. Okay, because if you reverse the direction of drive cell, that means the current will flow in this direction, and the connection of the diode, it will become forward bias. Okay, so both also can. Next. Okay, next. Diagram 3.2 show a full wave rectification circuit that consists of 4 component X, which are connected to an alternating current supply and a cathode ray oscilloscope. Okay, when the cathode ray oscilloscope is switched on, the trace on the screen of the cathode ray oscilloscope is as shown in diagram 3.2. Alright, so the question. Complete the circle in diagram 3.2 by drawing the component X in boxes A, B, C, and D. Okay, so that means we need to fill in the diode here. So this is obviously the bridge rectifier. So you see here, top and bottom is connected to the power supply. So that means the connection of the diode must be left to right. Okay, left to right. So we draw like this. Okay, left to right. Okay, like this. Okay or not? Can or not like that? Actually cannot. Okay, why cannot? Because you see it is not joined together. If you draw like this, then wrong. You have to join. You have to draw the wire. Okay, draw that it connect. Okay, you must draw so that it connect. Then only consider as correct. Okay, like that. Okay. Next, a capacitor is then connected parallel with R2. Sketch the trace that will be shown on the cathodic oscilloscope screen in diagram 3.3. Okay, so what will it look like when we connect the capacitor? Okay, so when we connect capacitor parallel with this one, so that means smoothing will happen. Okay, we will have smoothing. Okay, so when got smoothing, okay, to help us draw the diagram for smoothing, so we can draw a dotted line for the original trace. Okay, we draw the original trace. Okay, and then after that we draw the line like this. Okay, down up and then go down and then up and then down, up, down, up, down. Okay, like this. Okay, so this video what it look like lah. Okay. Okay, continue. Okay, next. Diagram 4.1 show a process of nuclear reaction that takes place in a nuclear reactor. This process occurs continuously. So we can see neutron go into this uranium, uranium split, okay, undergo fission and become strontium and xenon, and release two neutrons. So these neutrons go into another uranium, the uranium also split, becomes strontium and xenon, okay. Okay, name the nuclear reaction. So this is nuclear fission. Okay, this is nuclear fission. Next, write a nuclear reaction equation that occur in diagram 4.1. So this one is neutron go into uranium, uranium split into strontium and xenon and release two neutrons. So the nuclear equation will be the uranium okay, 235 92 plus 1 neutron 1 0 and then become strontium 9438. 9438 plus xenon 14054 plus 2 neutron 0 1. Okay, like that. So in this case, we must follow the diagram 4.1. This diagram 4.1 shows that only 2 neutron is released. Okay, so we must follow 2 neutron only. I know that in the chain reaction that we usually see, it will have 3 neutron. But in this case, they give us that 2 neutron released, so we must follow 2 neutron. Okay, because the question also say, write nuclear reaction equation that occur in diagram 4.1. Okay, so we must follow the one in the diagram 4.1. Okay. Okay, next. See, okay, table 4 show the mass of each nuclei in atomic mass unit. So this is uranium-235. The mass in atomic mass unit, xenon, strontium, neutron. Okay, so calculate the mass defect of the reaction in unit kilogram. Okay, so the mass defect is 235.04395. That means the mass of the uranium, the mass of uranium plus the mass of 1 neutron, 1.00867, minus the result of the nuclear fission, so is 1 xenon, 139.9216 plus 1 strontium, 93.9154 plus 2 neutron, 1.00867. Like that. So it will be equal to 0.19828. This is in atomic mass unit. This is in atomic mass unit. So we need to change it into kilogram. The question say calculate mass defect in unit kilogram. So you need to refer to the formula sheet in front, formula sheet and the list of formula list and list for constant number in front to see 1 atomic mass unit is equal to how many kilogram. And then you multiply, you take 0.19828 atomic mass unit multiply by 1.66 times 10 power by negative 27, because 1 atomic mass unit equal to 1.66 times 10 power by negative 27 kilogram. Alright, and then we will be able to get 3.291448 times 10 power by negative 28 kilogram. You see here, I write the complete number. I don't round off. The reason why I don't round off is I see that we are going to need this mass in the next question. In the next question, determine the energy released in the nuclear reaction. Determine the energy released in the nuclear reaction. So in this one, we will need the mass defect. So I don't round off, because if I round off, there's a chance that the accuracy for this answer will decrease. Okay, the accuracy will go down. So I don't round off, I write the whole thing. So E equal mc square. Okay, if you want to determine the energy release in nuclear reaction. Okay, so E equal mc square. So the mass defect, mass defect 3.291448 times 10 power by negative 28. Okay, times the speed of light square, 3 times 10 power by 8 square. Okay, so equal to 2.96 times 10 power by negative 11 joule. Okay, wait. Okay. Diagram 4.2 show a cross-sectional of a nuclear reactor. How the nuclear reaction in the reactor can be controlled. Okay, so here it shows us the control rod, the moderator, and uranium rod. Okay, how nuclear reaction in the reactor can be controlled. Okay, so the only way that we can control the nuclear reaction is by using the control rod. Okay, by using the control rod. So the first thing that we say is use control rod to trap neutron. Okay, lower the control rod between the uranium rods to decrease nuclear reaction. Okay, all right. All right, next number 5. Diagram 5.1 and 5.2 show two toy cars that are remotely controlled using radio wave from their respective controllers. Okay, wait. Okay, from remotely controlled using radio wave from their respective controller. Okay, so this one controller A, it can transmit frequency 2.7 times 10 power by 7 hertz. Okay, so this X is the maximum distance of the radio wave emitted by the transmitter that can be detected by the antenna. Okay, so F is frequency of radio wave. Alright, so we see that this one frequency is lower frequency, and then the range is 60 meter. This one frequency is higher frequency, and the range is 90 meter. Okay. Okay, underline the correct answer. Here, underline the correct answer. The speed of radio wave is what? The speed of light in air. Okay, the speed of radio wave is equal to the speed of light in air. But actually got become slower a little bit lah. Okay, actually got become slower a little bit. Okay, but the difference is very small that we ignore lah. Okay, we ignore that small difference. So we take it that the speed of radio wave is equal to the speed of light in air. Okay. Because every time we calculate that the frequency or the wavelength of the electromagnetic wave in air we will take the speed of the electromagnetic wave as speed of light. So in air, we take it as equal to the speed of light. Okay? Okay, so speed of radio wave is equal to the speed of light in air. Okay, next B. Observe 5.1 and 5.2. Okay, compare the frequency of radio wave emitted by transmitter of controller A and controller B. Okay, so frequency A less than B. Okay, frequency of radio wave emitted by transmitter of controller A less than B. Okay, so you can answer like this. Just write the minimum. That means what is the physical quantity that you are comparing? You are comparing the frequency. So you write frequency. Okay, and then the two things that you are comparing, A and B. And then the word that show the comparison. Less than, more than, equal to. So please write all of this to give a complete answer. Of course, if you want to use symbol also can. For example, if you write A less than B, okay, like this actually also can, but not recommended okay, not recommended, because if you accidentally write like this, accidentally write the symbol look like C, then the examiner will take it that it is a C okay, the teacher that mark your paper will take it that this is C, so it becomes ACB, and it becomes wrong okay, understand? So the best is you write words, okay, you write words is the best Okay, so next, tick for the correct answer. Okay, tick for the correct answer. Okay, toy car A still can be controlled even though distance is 80 meters from the controller. So this cannot because just now it showed that the maximum, you see X is the maximum distance of radio wave emitted. So the controller A only can reach 60 meters. Controller B can reach 90 meters. Okay. So A is wrong A cannot be controlled when the distance is 80. B still can control even though distance is 80. Then this one is correct. All right. Okay, next. Calculate the wavelength of the radio wave emitted by the transmitter of controller A. Okay, so to calculate the wavelength, so we need to use the wave speed and also the frequency. Okay, so by using the equation of V equal F lambda. So you want to use V equal F lambda also can, or you want to write C equal F lambda also can. Okay, it's not important whether V equal F lambda or C equal F lambda. Okay, next. So this one, the wave speed is in the speed of light. So 3 times 10 power by 8. The frequency for the controller A is 2.7 times 10 power by 7. Okay, lambda. So the wavelength for the controller A will be 11.11 meter. Okay. And then for controller B, same thing also, V equal F lambda. So 3 times 10 power by 8 equal to the frequency 4.9 times 10 power by 7 times the wavelength. So the wavelength will be equal to 6.12 meter. Okay, continue. Based on the answer in 5C, state the difference between the wavelength of radio wave emitted by controller A and controller B. So we want to state the difference between wavelength. So obviously, wavelength, compare the wavelength. So the controller A have longer wavelength because the frequency is lower. Frequency low, then the wavelength will be higher. Okay, wavelength longer. So wavelength A greater than B. Okay, like that. So again, same like just now. What is the physical quantity that you are comparing, and then what is the two things that you are comparing, and the word that show the comparison, the word that show which is bigger, which is smaller. Okay, so these are the important things that you need to write lah. Okay, next. Based on your answer in 5C and 5D, relate the frequency f and relate frequency and maximum distance of the radio wave that can be detected by the antenna. Okay, so from here, based on this answer, we can, based on this question, we can see that the greater the frequency, the greater the distance. Okay, just like that. The important, you have to write the what are the physical quantity that you are relating. Okay, the physical quantity is frequency and the distance. Okay, maximum distance also can or distance. So and then you have to write the word that show is it greater or is it higher, bigger, like that. Bigger, smaller, more than, less than, okay, all that. Okay. Next. Okay. State the relationship between frequency and wavelength. Okay, so what is the frequency? So from here we can see that the greater the frequency, the shorter the wavelength. Okay, the greater the frequency, the shorter the wavelength. Okay, next. Diagram 6 show a multi-tap transformer. Multi-tap transformer means that it has more than one terminal for the output lah. Okay, that means you can connect DF, DE or EF. Okay, there are three types of setting. So this is what we call a multi-tap transformer. Alright, so the primary coil have 1000 turn, AC power supply 240 volt. The secondary coil, the voltage of secondary coil is 60 volt. And then this one, the voltage D to E is 48 volt. The number of turn DE is 200. So this EF voltage don't know, the number of turn EF don't know. Okay? Alright. So here we have a table. So in this table, the primary coil and secondary coil. So primary coil number of turn 1000, input voltage is 240 volt. Okay. Secondary coil, DE terminal and EF terminal. So DE terminal number of turn 200. Terminal EF don't know. Okay, for DE the output voltage 48. For EF we don't know. and then the output voltage across the secondary coil. That means the total okay, is 60 volt. Okay, next. What is the type of transformer shown? Okay, so you see this transformer is where 240 volt becomes 60. The voltage go down. So that means this is step down transformer. Okay. Determine the value of EF, number of turn EF, and the voltage of EF in table 6. Alright, so we need to calculate that. Okay, so if you want to find out the number of turn EF or the voltage of EF, so what we need to do is first we need to know the total number of turn in the secondary coil. Okay, the total number of turn in secondary coil. So total number of turn in secondary coil. Okay, so we can calculate with V voltage in primary over voltage in secondary equals to number of turn in primary over number of turn in secondary. Okay, and then voltage in primary is 240. Voltage in secondary is 60. Number of turn in primary is 1000. So number of turn in secondary is 250. Okay, 250. Okay, so now we can determine the number of turn in EF. If total number of turn in secondary is 250 and number of turn DE is 200, so that means we have 50 in EF lah. Okay, and then if the voltage for DE is 48 and the total is 60 volt, so that means we have 12 volt. Okay, 12 volt for E to F. Okay, so this one total here to here is 60 volt. Here to here is 48. So that means here to here it will be 12 volt. Alright. Okay, very simple. Okay, next, see here. Based on diagram 6 and the answer in 6b, compare based on diagram 6 and the answer in 6b, compare number of turn in primary, number in DE, and number in EF. Okay, so very simple. Number of turn in primary is more than number of turn in DE, more than number of turn in EF. Okay? And then compare the ratio of voltage in primary to voltage secondary with the ratio of number of turn in primary to number of turn in DF. DF is the whole, okay, DF is the whole secondary. Okay, so that means the ratio will be the same. Okay, so all you need to do is just write same. Okay, ratio of VP to VS same with ratio of NP to NDE. Okay, NDF. So same. Okay, just write same. Next. Compare voltage in primary, voltage VE and voltage EF. Okay, so voltage VE, EF, this is wait, this is voltage. Okay, so the voltage in primary, again, it will be larger than voltage VE. Voltage VE larger than the voltage EF. Okay, continue. Okay, based on the answer in 6C, state the relationship between the number of turn of coil and the value of voltage. Okay, what is the relationship between number of turn of coil and the value of voltage? So you can see that if you have more number of turn, then the voltage will be higher. When you can see this, because first you can see the number in primary coil and secondary coil. Primary coil more, secondary coil less. So more coil means higher voltage. And then you can also see from DE and EF. DE have more coil, DE have higher voltage. EF has less coil, EF has lower voltage. Okay? So relationship between number of turn and value of voltage is the greater the number of coil, the greater the voltage. Okay? E. If the power supply in primary coil is replaced with direct current power supply, state the value of current flow in secondary coil. Okay, so we change to direct current. So what will be the value of current? There will be zero current, 0 ampere. Okay? Or you can just write, or you can write 0 also can. The word zero, Z-E-R-O, also can, no problem. Okay, so why when replaced with direct current, then there will be no current? Because transformer only can function when supplied with alternating current. Okay, if you supply with direct current, then it cannot function. Okay, so the secondary coil will have no current if supplied with direct current. Okay, diagram 7 show an athlete spinning a hammer in an hammer throw sport event. The centripetal force acting on the hammer when rotated is the tension of the string. So what is centripetal force? Okay, centripetal force is the force that act on a body in a direction towards the center of circular motion of the body. Okay, centripetal force that act on a body in a direction towards the center of circular motion. Okay, next. In diagram 7, mark the direction of centripetal force acting on a hammer. So the direction of centripetal force will be towards the center like this. Okay. Okay, next. The hammer of mass 4 kg is rotated in a horizontal circle of radius 1.6 meter with a linear speed of 25 meter per second. Calculate the centripetal force acted on the hammer. Okay, how do we calculate centripetal force? So the relationship okay, is force, okay, the centripetal force equal to the mass times the velocity square over the radius. Okay. Okay, centripetal force equals to mass times the velocity square over the radius. Okay, so the mass is 4 kg, the velocity is 25 square, the radius 1.6 meter. So we get 1562.5 Newton. Okay. Okay, next. Table 7 show the characteristic of the F, G, and H hammer throw involved in a hammer throw sport event. Okay, so we have three different type of hammer. Okay, F, G, H. So length of steel string, this one F is the longest, H is the shortest. Linear speed, this one 24, this one 20, this one 29. Okay, based on the specification, state the suitable characteristic of the hammer throw that has the highest rope tension when it is rotated. So give reason for the suitability for each of the characteristic. Okay, so first we look at the length of the steel string. So we want the length to be short. Okay, length of steel string should be short. What is the reason? Centripetal force is inversely proportional to the radius. Okay, so we can see this relationship from the equation. F equals to mv square over r. Okay, so this is the radius. Okay, this is the radius. This is the this is linear speed. Okay, linear speed. And this m is of course the mass of the object. Okay, so F is the centripetal force. Okay, so here we can see that the centripetal centripetal force is inversely proportional with the radius. So that means if the length of the steel string is short, then you can have a bigger centripetal force. Next, linear speed of hammer when it's rotated. Okay, linear speed high. Okay, high. So what is the reason? Okay, centripetal force. Okay, is directly proportional. Okay, directly proportional with square of linear speed. Okay, if you say directly proportional with linear speed, then it will be wrong. Okay, you cannot say direct proportional with linear speed. So it must be direct proportional with square of linear speed. Okay, so that means we want the short one and the fastest one. So based on answer in 7D, which hammer throw has the highest rope tension when it is calculated? So H lah. Okay, hammer throw H. Okay, diagram 8.1. Okay, diagram 8.1 show an airplane when it is at cabin altitude, which is 2,134 meter, and when it is at cruise altitude, 10,973 meter. Okay, at cabin altitude, the pressure inside the cabin is 77.9 kilopascal. That is equal to the atmospheric pressure on equivalent altitude. Okay, so the atmospheric pressure dropped to as low as 22.8 kilopascal at altitude of 10,973. Okay, so basically it means that when the pressure when the aeroplane is at 2,000 meter, okay, the pressure is already quite low compared to on the ground. Okay, compared to on the ground, and when it go up until go up until the cruise altitude, okay, cruise altitude, then the pressure will drop until 22.8 kilopascal, so which is very low lah. Alright. So here we can see the graph, okay, the altitude. So when climb up, okay, until cruise altitude, then is 10,000 meter, and then go down, okay. Okay, so part A. Define atmospheric pressure. So what is atmospheric pressure? Atmospheric pressure is pressure due to weight of the layer of air acting on the surface of the earth. So this is atmospheric pressure. Pressure due to weight of layer of air. So the air have weight and it press down on us. So the weight of the air is the force that act on the surface. So force act on surface, you get pressure. Okay, so how might the human rate of breathing change at high altitude? So at high altitude, okay, rate of breathing will increase. Okay, so why rate of breathing increase? Because density of air decrease and concentration of oxygen decrease at high altitude. Okay, so we breathe faster because the amount of oxygen is lower at high altitude. So when the oxygen is less, then in order to get enough oxygen, we need to breathe faster. Okay, next. Most commercial jets use air that enter the jet engine to provide air to the cabin during flight, as shown in diagram 8.2. Okay, the air is then processed, cooled, and finally piped into the cabin. So the pressure in the cabin is kept between 75.8 kilopascal and 82.7 kilopascal to ensure that the passenger and flight crew can breathe easily. Okay. Okay, what is the method can be done to ensure that passenger of the airplane get enough air at high altitude? Okay, so how is it that you can make sure that you get enough air? So you can pump more air in, okay? Pump more air into the cabin. Okay, so the reason, concentration of air, concentration of oxygen. Okay, oxygen is lower at high altitude. Okay, next. Okay, suggest action to be taken if there is passenger suffering from a lack of oxygen absorption in his lung during the flight. Okay. So what it should be do is okay, let passenger breathe from oxygen mask or oxygen tank lah. Okay, oxygen mask lah, oxygen mask. Okay, so concentration of oxygen from oxygen mask supply is greater than air at high altitude. Okay, concentration of oxygen from oxygen mask supply is greater than air at high altitude. Alright. Okay, next. Diagram 8.3 show a side view of an airplane window design proposal. Okay, take the correct design of the window to create a safe pressure difference between the air inside and outside the airplane. Okay, so the most suitable is this one. This one is most suitable. Why? Okay, because the pressure inside is higher than outside. So if it's curved, then the force from the pressure can be distributed more evenly. Okay, can be distributed more evenly, and so it won't cause the wall or the window to break lah, okay, or to bend like that. Okay. So the justification, able to resist greater force from inside due to greater pressure inside the airplane. Okay. Okay, so the section A of the of SBP paper, okay, finish here. Okay, ready, this is Selangor set 1, okay, set 1 Selangor section C, okay, section C. Okay, so let's look at Selangor section C. Okay, diagram 11.1 and 11.2 show refraction of light through two medium of different density. Okay, refractive index of medium X and Y are 1.51 and 2.05 respectively. Okay, so this medium X, the refractive index is 1.51. This one, the refractive index is 2.05. Alright. So what is the meaning of refraction? Okay, so refraction is the bending of light when propagate between medium of different optical density. Okay, refraction is the bending of light when propagate between medium of different optical density. Alright. Next. Okay, V1. Compare the incident angle, the refracted angle, and the refractive index between medium X and medium Y. Okay, you need to compare these three things between X and Y. Okay, so the first one, okay, we look at incident angle. So incident angle, both also same. Okay, incident angle, same. So you must answer. What is it that you are comparing? You are comparing incident angle. Okay, incident angle of X same as Y. Okay. Oh, sorry, no sound. Alamak. Oh my God! Just now I got talk about a lot of things. Then let me begin here. Okay. Never mind. Maybe it's inside the recording lah. Okay. I think it's inside the recording. Okay. Okay. I think it's inside the recording now because the recording is separate from the Google Meet. Okay. The recording is one program and the Google Meet is in another program. So I think it will be inside the recording. Okay. So continue. Okay. So incident angle of x same as y. All right. Next, we want to compare refracted angle. Okay, we look at the refracted angle. So x is 35, y is 25. So x bigger than y. Okay. So refracted angle of x. Okay, refracted angle of x. Okay, wait a minute. Greater, yes. Okay, greater than y. And then the third one is you want to compare the refractive index. Okay, so refractive index of x is less than y. Okay, make sure that you compare. When you compare, you must write each one separately. You must separate each one. Okay, like that. And then the second one, relate the refracted angle with refractive index to make a deduction on relationship between refractive index and density. Okay, so refracted angle and refractive index. So the greater the refracted angle, the lower the refractive index. So this is relate. Relate, that means you need to write relationship. Okay, the greater the something, the lower the something, relationship. Okay, next is relationship between refractive index and density. Okay, so is there anything that tell us about density? Okay, it just says that different density, but it doesn't tell us about. That means only from the refractive index we can guess we can deduce the density. Usually object of greater density will have greater refractive index. Usually like that, but that is not always because density and refractive and density and optical density is actually two different things. Okay. But this question here it says density. Maybe it refer to optical density lah. Okay, optical density. But never mind. We just we answer follow what the question want. Okay, so okay we answer follow what the question want. Okay, so the greater the refractive index, the greater the density. Okay, just like that. You see on the road, there is a reflector, okay, that is installed on the road. So the concept is the same, where the light go in to the prism, experience total internal reflection, and come back out. Okay? Yeah. Okay, so you are assigned to give suggestion on the characteristic of the reflector so that it can be used to reflect high intensity of light. So state and explain your suggestion based on following aspects. So angle of prism, material of the prism, characteristic of the cover, number of prism, position of the reflector. Alright. So we answer this kind of question with table, okay, in table form. Okay, this kind of question we answer in table form. Alright, so this is the characteristic. This one is the explanation. Okay, so the first characteristic, angle of prism. Okay, angle of prism should be 45 degree, 90 degree, 45 degree. Okay, so you can write like this, or you can draw also can. That means you draw like this. Okay, you can also draw. You show that this is 90 degree. Okay, 90. This one is 45. This one is 45. Okay, you draw also can. In physics, the way that you present your answer is very flexible. Okay, if you think that you don't know how to write what is the angle of prism, then you draw. Okay, to show people like this, no problem. Okay, okay, so explanation. So that incident angle is 45 degree. Okay, that means the incident angle onto the back of the prism. Okay. Next. Okay, so the second one is material of the prism. So we use material of prism should have high optical density. So you can say it have high optical density, or you can say that it have a high refractive index also can. Okay. Smaller critical angle, easier for total internal reflection to occur. Okay. Next. Okay, characteristic of the cover. Okay, so this cover. Okay, so we say that the cover should be the cover, of course, it must be transparent. Okay. Okay, cover. The characteristic of cover. Cover should be transparent. Okay, allow light to pass through easily. Okay, the fourth one, number of prism. Okay, number of prism should be more. Okay, able to reflect more light. Wait, let me check the question. Reflect high intensity of light. Okay, inside the question it say it can use to reflect high intensity of light. Here we can say that it reflect more light. Okay, also can because it's not like exactly the same as inside the question. Okay, or you can say it reflect more light or reflected light can be brighter, also can. As long as you don't use back the same word okay, more light intensity, okay, more intense light, like that cannot, okay, because it's already inside the question. Okay, so the fourth one, the fifth one is position of the reflector. Okay, position of reflector should be at this is bicycle one. Rear reflector of bicycle. Okay. Okay, position of reflector should be at the at a higher position. Okay, position, higher position. Okay, so easy to be seen by uh, car driver. Okay, like that. Okay, so this is the answer, how we answer. Okay, so okay, I know already 4 o'clock. Okay, a little bit more. We finish off we finish the whole question. All right. No more space. Okay, so diagram. Okay, diagram 11.4 show a light ray passing into diamond. Critical angle of diamond is 24 degree. X is the incident angle. Okay, explain what will happen to the light ray at point B if x equals to 20 degree and x equals to 30 degree. Okay, so let me write the answer here. Okay, so because the critical angle is 24, so that means if the angle of the light is 20 degree, so that means it will not have total internal reflection because it's less. Okay, so what will happen to light ray at point B if x equal 20 degrees? So first is light will exit the diamond at point D. And refract away from normal. Okay, because angle of incidence is lower than critical angle. Okay, and then the second one, 30 degrees, so more than critical angle already, so light will reflect back into the diamond totally. Okay, total internal reflection occur because incident angle is greater than critical angle. Just like that. Okay, very simple. Okay, so with this, we finish up the section C of Selangor. Okay, so if you have any questions, so please you can stay back and ask lah. Okay.